Hey, welcome back. Today I'm going to show you how I organized my tool drawers by 3D printing tons of these organizers that are based on the Gridfinity system, so let's jump right in. This might be surprising to a lot of you, but my favorite object in this entire workshop actually isn't a tool or machine of some sort, it's this tool cabinet. This thing is all steel and it weighs over 300 kilograms empty, and it's made by a company called Lista, and they make about the highest quality functional furniture out there. Normally these things cost an absolute fortune, but some years ago I got incredibly lucky and was able to score this used for a really good price, and it being used really makes no difference because these things will last you a lifetime. I love the layout of this because it has these gigantic flat drawers that are perfect for storing a huge amount of tools while wasting as little space as possible. So almost all of my smaller tools live in this cabinet. The drawers on this are rated to carry up to 120 kilograms each, which is insane, and that's why a lot of places also use these to store materials. You can get a ton of accessories for these cabinets to organize the stuff within them, and for a lot of things I'm using those, but the topic of this video is custom storage, so let's get to the point here. One thing that the storage solutions that come with these cabinets don't work well for is my measuring drawer. I got a lot of stuff in here that doesn't really fit into any ready-made compartments, and while it looks somewhat organized here, nothing really has a fixed place, and the bigger issue is that when closing the drawers, things tend to slide around in there and also bump into each other, which is something you want to avoid with measuring tools like these. So I figured I'd take some time to come up with a solution for this, and if you watched my recent videos, you know I've been playing around with Gridfinity a lot, which is perfect for this application. Gridfinity is basically just an open source framework for making organizing systems, and it's all based around this grid system that you can print yourself and then either use existing models like these basic bins here that fit into the system, or make your own custom ones, which is what we're going to do today. While we're at it, another drawer I want to tackle is the top one, which mostly contains a big socket set and various other bits and adapters. While storing this inside the case it came in works okay. I'm not a big fan of these blow molded cases. They work okay if you're actually moving around with your tools, but since this always stays in the same place, plucking these tools out of their molds and putting them back in is pretty inconvenient, and this thing is also not very space efficient, so I want to fix that by making custom organizers for this one as well. So next I'm going to show you the process of how I actually designed and made all these things, and show you some different workflows. There's different ways of how you can model the molds, and it depends a little bit on the shape of the tool, so I'm going to start with a fairly basic one like this square here. For something like this, the easiest way is to just measure the basic dimensions and write them down. Since this is a very simple geometric shape, this should be easy to build in CAD even for a beginner. Once you know the overall size of the object, it's now time to translate that into a Gridfinity grid. In this case, the object is about 205 by 130 millimeters long, so all you're going to do then is divide the length and width by 42, which is the standard grid size, and then round up that number. For example, in this case the length comes out to 4.88 grid units, so we can round that up to 5. And doing the same with the width, we now know that the container for this needs to be at least 4 by 5 units. So next let's jump into CAD to actually create that container. I'm using Autodesk Fusion, but you can generally create these assets in pretty much any CAD software. Fusion just happens to be the most convenient right now because people have already created some tools to make this as easy as possible. One of them is using the template from Zacks, which you can find under his Gridfinity introduction video that I'm going to link in the description. This is basically just a Fusion file that contains a dummy Gridfinity box and grid, and it has variables set up that you can change to make it any size you want. That being said, if you want to make more specific changes to the model, you'd have to start going into the timeline here to deactivate or change some features. But there is an even easier way of doing all this, and that's using the Gridfinity generator plugin you can find on the Autodesk App Store. You can just download this plugin for free, and it's super easy to install into Fusion, and once you've done that you're going to find a new button that lets you open up this menu. This allows you to not only create a blank Gridfinity block any size you want, but there's also tons of additional settings, and you can even use this to make bins with custom divisions already built into them. In this case all we really need to do is to set up how many units we need in the XY direction, and then also the height of the box. The height units are multiples of 7, and I would always make these boxes just tall enough to fit the tools to save filament, so this depends a bit on how thick the tools are. As for the other options, I usually pick solid here since we're going to extrude our shapes into the block, and as I mentioned, I usually deactivate all the holes on the bottom and also the lip that enables you to stack bins on top of each other, since that's not needed here. So now that we have our blank box, I just create a sketch on the top surface and start drawing the shapes according to what I just measured, which is really simple in this case since it's all just rectangles. Once that's done, I can just extrude these shapes into the blank as deep as I need them, and of course you want the objects to stick out a little bit, or add some holes to make sure you're actually able to grab the object. Now the fact that Gridfinity is based on a grid means these tool organizers are usually going to be rectangular, although it is possible to make other shapes, and I'm going to show you an example of that later. But what that means for us right now is if we make an organizer that's 4x5 units and we just put this one tool in it, we'd be wasting a huge amount of space for nothing. So what I did with these was to just try and find combinations of tools that I can fit together in the same space to utilize the most of that area. I did usually try to group similar tools together, but sometimes I also ended up compromising on that idea to use the space most efficiently. With that, this simple organizer is already done and ready for printing. There's only one thing to keep in mind, which is that you need to account for tolerances in your model. This depends a bit on your printer, but generally you want to add something around 0.5 millimeters to your outer dimensions to avoid the fit being too tight. So here's the actual print now. Quality-wise, this came out great as always, but this was the first one I made and I promptly messed up because I got some kind of measuring error in there, causing this shallow edge here to be too far down. But it's a very minor mistake, so I didn't feel like it's worth reprinting the whole thing, and luckily everything else fits very nice. But it goes to show that you really want to triple check all your measurements before you start printing something like this. As for the other two openings, I still had some space left, so I figured I'd just use that for these threading gauges. I used the same approach you just saw for most of the tools that have simple shapes, so now let's see what we can do about slightly more complex shapes. A good example for this is this digital caliper. You could of course take a lot of measurements to create the outline for this, but nobody got time for that, and it's not critical that the shape is absolutely perfect. So my solution for this is to work off a reference image. For that I'm placing this on my cutting mat, which is very useful for this kind of thing, as you'll see in a second. I've lined up the straight edge on the tool with the grid on the mat, and now I'm going to take a reference picture of it. And for this you want to make sure you take the picture from straight above and right over the center of the object to minimize any perspective distortion. On most phone camera apps, when you hold the phone like this, you actually get this little dot in the center, which is basically a water level. So in this case the dot goes yellow once the phone is perfectly level, and that's when you want to take the picture. Now I can load this image into Fusion using the canvas function, and now I'm going to show you two reasons why it's incredibly useful to have the grid in there. First of all, I can now use the grid to rotate my reference picture if necessary, so that the lines match up with the digital grid, and I can also use it to get the scaling right. Fusion has a feature for this, which is called Calibrate, and when you click this, it lets you draw a reference line that it's then going to use to scale the canvas so that it matches the scale of the virtual space. Since I know that the lines on this grid use a 10mm spacing, I just look for a place where the lines have the least distortion, which is going to be towards the center of the image, and then I just draw a line exactly 5 squares long, and I tell Fusion that this is 50mm. And it's now going to scale my canvas accordingly. Now that a reference image is scaled and rotated perfectly, I can use this as a template to draw a sketch outline around the object and then extrude that into my blank box. When I started using this method, I was always a little paranoid about the prints ending up way too tight, so I added way too much tolerance around the shapes, which as it turns out isn't actually necessary. Over time I figured out that if you take a really good picture and adjust the canvas carefully, this method is actually surprisingly accurate, and I could have added way less tolerance, but then again it's not a big deal for this to float in there a little bit. And if you're wondering what the other space in the box is for, it's for this protractor, which happened to fit together with the calipers quite well after adding a little bit of overlap. And as you probably guessed, I modeled the shape for that one by hand because it's really just a circle and a rectangle, so no need for a reference picture for this one. So next, let's step it up a little bit and check out something even more complex, which is these digital micrometers. Again, modeling these by measuring every detail on them would take way too long for what I'm trying to achieve here. So I once again took a reference picture and drew the outlines, and while the objects before were pretty flat, these also have a more complex shape in the vertical direction. But instead of recreating the exact shape, I mostly just looked at the difference in thickness between different surfaces on the bottom of these and measured the knobs in the back to extrude some cylinders, and just kind of approximated where the molds would need some clearance in them so the objects don't wobble. And again, I added way too much tolerance around the outside to prevent a misprint, and also had to add a little rubber strip here because the larger one wasn't balanced well. So while this box works fine in general, it could use some improvement, which brings us to another method to approach this. There actually is a way to get a real-life object into a 3D application that doesn't involve any modeling, and that's called 3D scanning. There's multiple ways to scan objects, like photogrammetry, where you use pictures of an object to try and generate a model. but the best way is to use a dedicated device for this called a 3D scanner. And it was actually completely by chance that when I was almost done with this project, I was approached by a company that makes 3D scanners. So big thanks to RevoPoint for sponsoring this video by sending me their flagship scanner, which is called the Morocco. Unlike other scanners which often work in conjunction with a smartphone, this is actually a completely independent device that has everything built into it to create scans from start to finish. It looks and feels a little bit like a DSLR camera, except that it doesn't have one big lens, but rather this whole array of sensors that's used to scan objects in real time. It also comes with a ton of accessories and feels like a really high quality device, which is backed up by some impressive technical specs. After some setup, you can immediately start scanning stuff, and there's a few different ways to use this device. For small to medium sized objects, there is the classic way that lots of these scanners utilize, which is to put the object on this little turntable, which comes with the scanner. With this you can spin the object around while the scanner remains stationary and captures data from all sides. But with the Morocco you don't actually need that, because you can also move the scanner itself around the object while it captures data automatically. The cool thing about this is that it not only lets you capture small objects, but it actually has a near mode and a far mode. So in far mode it allows you to capture fairly large objects by walking around them, which is what I did with my bandsaw or with this toolbox here. Once you're done scanning, you can either process the models directly in the scanner, or you can put them onto a computer and use the software that comes with the scanner. And this is used to refine and finalize the models, for example by deleting bits of the model you don't need. So I scanned my palm center here just as a test, and in the model you can really see the high resolution you're able to capture with this, where even the small surface details like those dimples on top are fully present. Another really cool feature is that you can even capture objects in full color, so here's a fully textured version that you could use as an asset for 3D rendering. So to give you a practical example here, I scanned this infrared thermometer to make another custom organizer for it. This object is a good example of how the scanner saves you a ton of work, because it has a pretty organic shape that would take a lot of time to recreate in CAD by hand. After scanning this and refining the model, I then created another Gridfinity block in Fusion and converted that into a mesh, and then I just imported my scanned model and used the combine function to cut a negative of that shape into the box. I then exported this to the bamboo slicer and also added a bit of extra clearance by using the horizontal hole expansion parameter to make sure it doesn't sit too tight in there, and then I just hit print. The scans from the Morocco are very accurate with precision up to 0.02 millimeters, so it wasn't surprising that this fits in there perfectly, and I once again probably could have added less clearance if I wanted this to be even more form-fitting. So overall I think this device is super useful for any kind of prototyping, and of course very powerful in conjunction with a 3D printer especially. The Morocco has tons of other features I can't go over in this short presentation, but if you're interested, you should definitely check out the links in the description where you can find more info and also a discount code. And you might also want to check out their YouTube channel, which has a lot of tutorials and examples around 3D scanning. And with that, let's get back to the project. Like I mentioned, I didn't get my hands on the scanner until after I was basically done with this project, which is why I made most of the organizers the old-fashioned way. So here's a few more of those, most of which are quite simple. I made these for some dial indicators, which unfortunately had to be pretty big at 2x6 units. But I also made these little 1x2 ones, which are perfect for the dial test indicators. Here's a bit of an odd one. This is L-shaped because I couldn't figure out a good use of the remaining space, and I'm pretty sure it's illegal to use Gridfinity like this, but it actually works out perfectly and happens to fit the boxes I showed you before on the side. Here's another one that has some slight vertical overlap that allowed me to squeeze these two tools into a 2x7 space. And so far with the overlapping ones, I've always managed to make them so that you can retrieve the tool on the bottom without removing the one on top. Here's another big one for some micrometers. Again, I used the reference picture method to make this and added a bit too much clearance here. And this is another case where I probably would have used the 3D scanner if I had it at the time, but this still works fine. With this one I've been cheating a bit because these things almost fit into a 4x2 space and I was too stubborn to make it bigger. So they stick out the side very slightly, but it's not an issue as long as this sits next to a piece of the same height. Here's another odd one. This is the only organizer I couldn't fit even on my large printer in one piece. But since all of these will be aligned on the grid anyway, it's actually a perfectly valid solution to just split them up. So I printed this in two pieces to fit this large combination square and the depth gauge. And once it sits in the grid, this acts as if it was one piece. So you can store fairly large tools this way, even if you have a small printer. With that, it's now finally time to put all this stuff into the drawers. So first I'm placing the grids, and then as always with the Gridfinity, you can spend an endless amount of time playing Tetris with these and moving everything around to find the best layout. And this is what I ended up with for now. Obviously this is a lot more tidy than before. Everything has its fixed place and nothing is able to slide around anymore. But what I was most surprised by is how much space this ended up saving, because I thought I might actually need more space in the end. But as you can see, there's still quite a bit of room if I want to add additional tools. With that, let's now move on to the socket set, which I also printed a bunch of organizers for. Luckily with these, the process is a lot more straightforward, since all of this is basically just cylinders, so there's no need to take any pictures or scans. I would just place a set of sockets on the grid and then figure out a good way to position them, which usually is just a straight line. And there's actually an even easier way to figure out how many grid units you need that doesn't involve any measuring, and that's to just use an existing Gridfinity print in case you have one. I got this basic bin here, for example, which tells me that fitting these into 6 units would be pretty cramped, but 7 seems to be a good spacing. So I just created a 1x7 blank in Fusion, drew a circle and used the pattern function to create a row of those. And then it just comes down to measuring each socket and changing the diameter accordingly. Once again, you do want to make sure to add enough tolerance. For this purpose I want these to be easy to retrieve, so I added about 0.3 of a millimeter to most of the holes, and that ended up giving me a fit where the sockets slide in and out of the holes pretty easy, but without having a lot of play. I also added some lettering to this box, and I have the luxury of being able to print it with up to 4 colors on my X1 carbon here, thanks to the AMS. So I made the letters white, and the reason this is gray on the bottom is just I happen to have a lot of cheap gray filament at the time. So I printed most of it in gray and then the top in black and white to improve the contrast. All the other boxes work the same way. I just grabbed a bunch of sockets and played around with the layout a bit. For the long sockets, I can't store them standing up because they won't fit in the drawers that way. So these are laying flat, but it's basically the same process, except you just extrude the cylinders sideways. And for these sockets that have significant tapers, I also added a little step so they don't wobble. The small bits here are even easier. These all have the same size, so I really just need to measure one. And then I made these 1x3 organizers that fit 12 of them each. Then we have these guys, which are a little bit bigger than normal screwdriver bits. So I just used the same box layout I just showed you, except with hexagonal holes. And then for all the small bits, this is the only one where I got a bit lazy and used models I found online and modified them a bit. Although I probably could have modeled them myself in the time it took me to find and download them. I also downloaded this design for the longer bits, but I really can't recommend it. This is a pretty poor design because they tend to fall out super easily, but it's gonna do for now. This one for the long bits, on the other hand, works perfectly. Then it was time to sort all the bits into these containers. I generally suggest to stick with the 1x1 bins for most of this stuff, because those allow you to organize bits a bit better by making small groups, but the large ones work well for stuff like these various oddball security bits that I never use anyway. Now it's time to finally empty that blow molded box the socket set came in, and yes, this was just as satisfying as it looks. One thing I really like about this whole custom organizer thing is that it lets me consolidate different tool sets into one cohesive system. So for example, I have a bunch of additional small sockets from another set here, and I can now combine all of these together and get rid of all the bulky cases. I then emptied out the drawer again, and you're probably wondering why I didn't make any molds for the ratchets and other accessories. And the reason is that, as I mentioned in the beginning, the Lister cabinets come with their own organizing system, which actually works perfectly for that kind of thing, so I'm going to use a combination of those methods. The system is based on these cylindrical trays, which really are kind of genius. They come in different sizes and can be attached together to create rows as long as you want, and then you can add dividers to create individual compartments. So it's a very flexible system, which is absolutely perfect for storing stuff like drills, or anything where you might want to change the layout frequently. Just like Gridfinity, this system is super satisfying to use because it feels a little bit like playing with Legos. So I think these two are a great combination, and I probably don't need to mention you could also 3D print a similar system, but I'm pretty sure it would end up being more expensive than just buying them from Lista. The cool thing about this solution is that it's very adaptable for different sized objects. So I can now consolidate all my different socket wrenches, ratchets and extensions in one place. And there's also plenty of space for stuff like random sockets, all kinds of adapters, and anything that doesn't need to be in a labeled compartment. For example, I now have all the quarter-inch adapters from different sets in the same place, which makes a lot more sense than plugging them from 3 different cases. Now it's finally time to finish this by placing the printed organizers in here as well. And once again I'm playing around with the layout, which most likely isn't final yet. Once again, I was really surprised by the sheer amount of space this saved compared to the original box, but what's even better is that it's so much quicker and more comfortable to retrieve tools from here, because you can now just grab stuff and put it back without any resistance, and the clear labeling also really helps. Another cool thing is that I can now grab a whole bunch of sockets all at once and bring them to the workbench, which I think is gonna save me a lot of walking around, because I never bothered hauling around the entire case the way it was set up before. I think I'm done with this organizing madness, at least for now, because as satisfying as it is, I can't deny that it does take a lot of time, but I also know this kind of thing really pays off for years once you've done it, so I'd say it was definitely worth it. Hopefully you could take away something useful from this video, and if anyone happens to own the same socket set, I put the files for the socket organizers up on Etsy in case you're interested. That's it for this one, thanks for watching and see you next time.